Hi, in this tutorial we are going to see how to build a Jansen Walker. A Jansen Walker is a sort of a spider made by Theo Jansen. So first we are going to build a couple of shapes. These two triangles are going to be the elbows of a pair of legs. Then we are going to draw a legs, that is a triangle rectangle. Once we have our legs and elbows, we are going to set the names so as to help us when dealing with the shapes. It's pretty useful to have names so you can know in the body inspector, in the leg inspector, which bodies are available so that you can hide them. Now we are going to draw the base. The base is where everything will be sticked to. And now we are going to draw the wheel. The wheel is the main engine in this case, is the thing that will drive the legs, that will allows them to move. Now we zoom a little bit and set the revolute joint between the base and the wheel. We remember that we want the wheel to be the static body. Well, I'm sorry, to the base to be the static body for the wheel. Then we add the revolute joints for the elbows and the base. In the case of that revolute joint, we want the base to be the static body and the elbow to be the dynamic body. With that said, we will move our wheel slightly down just to arrange all the joints that will be moving our legs. For the joints we are going to use distance joints. We are going to joint it in the same arrangement as the Jansen Walker. For the joints, for the distance joints between the elbows and the base, we want the base to be the static body. So for both we make the joint and then we verify that the static body is the base. Remember that if we don't verify the correct static body, we may start to get strange tricks there. The system may behave erratically because the movements are not well processed by box2D. Now we set the joints, the distance joints between the legs and the elbows. In the case of the joints between the legs and the elbows, we want the elbow to be the static body and the leg to be the dynamic body. And when we joint the leg to the wheel, as we are doing now, we want the wheel to be the static body and the leg to be the dynamic body. We verify that the static body is correctly set for both cases. Now we are verify a little bit more with the joints. And now we are going to change the bits, the character bits of both the elbows and the legs. This in order to avoid problems by collisions, non-desired collisions between the legs and the elbows. Then at the end of the video we will reset these category bytes to the correct value, but currently we don't want them to make us problems. Now I just copy to the clipboard the legs and the elbows without the revolute joints. And now we are going to do a small trick. We are going to press the button of auto freeze, that is the ice cube with the A, and we are going to put the new arrangement of the legs, that is around 120 degrees of the wheel rotation from the original point. And when we release, the scenario will be freezed and then we can edit again. We will paste what we have in the clipboard and then we will hide the first elements, and when we are going to start to set the new joints for the new pair of legs. Remember that we still need to check that the static bodies are correctly set and that the dynamic bodies are correctly set for the new distant joints, and also for the new revolute joints we also need to check that. Remember, for the elbow and base we want the base to be the static body, for the elbow and wheel we want the wheel to be the static body, and from the legs and the wheel we want the wheel to be the static body, and for the legs and the elbow we want the elbow to be the static body. Then we check all the joints to see that they are correctly configured. Seems like they are okay. And now we are going to do the trick again of the auto freeze. We are going to set a small mark just to help us do this more fine. We are going to set it at the same level as the joint that we already have. We are going to click the auto freeze and we are going to place the new configuration. Now let's make this slightly more to the left, and there is it. Now then again we place what we have in the clipboard and start to join the last joints for our last pair of legs and elbows. Okay, now we start to join the elbows to the wheel. Remember, the wheel is the static body. Now we will set the elbows to the wheel to the legs. Remember, the wheel is the static body. And we will set the revolute joints. Remember, the base will be the static body. We check the joints for the revolute joints and they are misplaced, so we clicked switch static, switch bodies, and then we verify that the other joints are correctly placed. They seems like they are. So now we have pretty much all our legs in place. Let's test it to see how it performs. It seems to perform well, which is nice. We did a great job. So now we are going to do a small trick because we need the wheel to be centered with the base, but we don't want it to move to other place, so we are going to do a small trick. We are going to set a mark with first with the we are going to set a mark with the friction joint. We are going to place a prismatic joint to move it on a fixed axis, and then we are going to use the friction joint to keep a mark on what we want, and then we are going to place it at the center of the base, and there it is. Now we are going to replace the revolute joint. We are going to remove the prismatic joint, and that's it. Our Jansen Walker is complete. It performs well. We did that because there is no easy way to move the revolute joint without screwing all the distance joints. Now we are going to traverse all the legs and set the correct bits for the collisions. In that case, we want the legs to be of category 1, but not collide with category 1, but only with category 2. With this, we can make the floor to collide with with category 0, but the legs not to collide with themselves. So we are going to set all the legs to the same configuration. And that's it. Now we are going to draw a floor, which will be a static body. So for static bodies, we need to remember that we need to change the type to static. Now that it is, and we set the bytes, and that's pretty much what we need to do. We remove the wall joint, and there it is, our Jansen Walker. Now let's resize it to a more manageable size. We will set our small wheel to power the Jansen Walker. We could either use an engine, but just for these purposes, will be easier to set a free wheel and attach it to the Jansen Walker with a gear joint, so that we can change the movement from the direction of the movement. So we set our gear joint. Oops, let me change the radio of the, and there it is. Now we have a small Jansen Walker. We can make it move to left or to right depending on the movement of our free wheel. But obviously in code we can change it to use controls or something like that. As you can see, it performs well, so we didn't miss any joints. All the joints seems to be correct. No part collide with himself and make anything strange, so it seems to work very fine. Now remember that we can publish this, and it's automatically published to XML, and also a small shockwave file is generated, so you can embed it in the web page with Flash. Also, if you want to embed it with HTML5, you can take the XML file and use, for example, live GTX.